Hi there, Bill Benner here from Pangolin Laser Systems, and we got an exciting development to show you today. We just got a batch of these new green laser diodes in from OSRAM. Very exciting. This particular one is the PL520, 520 nanometer one. We got a bunch of these. I've been testing them all morning, and so I want to show you some really neat stuff about them, in particular with LASORB. First thing I want to show you is just how small they are. Take a look at that sucker. It's only 2.5 millimeters around and 3 millimeters on the widest part of the flange, so very small, much smaller than your typical red and blue laser diodes. Second thing is, check this out, the data sheet. Applications. The first application is laser projection. Second application, stage lighting. So that's pretty cool, and I think that our friends in the laser light show industry will find this very interesting, because now finally the laser light show industry has become such a big industry, now $250 million a year, that a company like OSRAM stands up and takes notice as it puts that as their first two applications for this new green laser diode. So that's pretty cool. Second thing is that the check the operating voltage out, 7 to 8 volts, and it really does that. I mean, the typical operating voltage we're seeing here at 160 milliamps is indeed 7 volts, and it gives you somewhere between 50 and 60 milliwatts out of the single green laser diode. So that's pretty cool. The last thing, it's not shown on the data sheet, but it's something that we determined here on our curve tracer. The dynamic impedance of this laser diode is 10 ohms. Now that's really pretty high for a laser diode, especially one with moderate power like this. Typical dynamic impedance of a red laser diode is somewhere around 1 ohm these days. A blue laser diode, well below 1 ohm. So to have a dynamic impedance of 10 ohms, that's really more along the lines of a lower power red laser diode. And so next thing I'm going to do is show you exactly how sensitive these things are to ESD and how they can be protected by LASORB. What I've got here is LASORB connected up to this green laser diode. I have the green laser diode kind of mounted on this piece of copper here so I can get a little bit of longevity out of it, and it'll act as a heat sink. And we have our ESD gun here set for 15,000 volts and 20 shots a second. So we're going to let the sparks fly and see how well this thing does when it's protected by LASORB. Here we go. I've got this just a cheapy battery power supply here. It's going to be supplying it with some power. And go ahead and turn that on. See the beautiful green color and 15,000 volts, 20 shots a second. You can see those sparks flying, right? No problem at all on the laser diode. Alright, so now let's do something a little bit different. We'll cut the LASORB off of this so that LASORB is no longer offering any protection. And I'll turn the ESD gun way down, somewhere around 6 kV. And on the single modes, we're just going to give it one shot, a 6 kV, unprotected, and let's see what that does. History. So as you can see, these green laser diodes really are sensitive to ESD. The data sheet gives us a warning about that. Sometimes we ignore these kind of warnings, but in this case it was true. And as you can see, when you protect the laser diode with LASORB, it can survive practically anything. So, hope you found that pretty cool. I think we did too. And check out these new 520 nanometer OSRAM green laser diodes, and when you do two things. One, make sure they're protected by LASORB, and two, check us out at lasorb.com.